All right, you were given a root of a binary search tree BST where the values of exactly two of the nodes have been swapped by mistake. Recover the BST without changing its structure. Okay. Okay. Let's think. Two examples here. Look at this example here.
But like for this problem, you really have to understand like pre-order, in-order, and post-order. Like, at what point do you want to like capture the node and compare it to the previous value?
That's exactly what I was thinking. You looking at the first example or second?
Uh, I looked at both already. The second one makes it a lot more complicated and understand. I mean, yeah, because like if it was just like the previous one, like right before it, was the only one that we would swap, I think that would be much easier. But if it could just be anywhere down the line of that tree, then
Nah, this is definitely doable. Something's missing. Something's missing. Mm. You have any ideas on like what you might do?
Yes. My thought process is like just like understanding like how do we capture like the previous and the current. So like we need to understand like as we traverse down the tree, uh which ones are previous, like where we find an error. So like let's say if we're looking at example one, if we're just traversing three to one, we're comparing the one or our previous to one, we see that this is a one, well, the initial tree is 1 to 3. So we see that one left is a 3. We know that it should be lower than 1, so we identify that its child, its next pointer is greater. So we say there's an error there.
Yeah.
And so I guess we take record of this and we don't swap it yet, but we just take record of this, I guess, because we need to swap it in place, which is also the thing. Um,
What? You have to swap in place. Oh, okay.
my research so far has shown that it should be an in order traversal, but I still don't understand the concept of like like if we understand in order, like the if this was like a BST, it would get the values in like a increasing or decreasing order, decreasing order, increasing order,
You said
right?
in order?
Yeah,
In
in order
order means
traversal.
you go left. Yeah, so it should go increasing. Get the smallest one first. Oh, maybe.
So if we do an in order, then like the
Hmm.
smallest one should be first.
Yeah, yeah. The first one would be the smallest number.
Yeah, it's tough. It's tough. I don't know. What do you think?
I think you just gave me like that. What you just said made something click. Let me make sure this works before I like start talking about it and it doesn't work.
Okay.
I think yeah, in order. Yeah. What do you guys know what that left? In order, we go DFS node dot left for regional. Boom, place the node. Go dot right. Boom, place the node. Okay. Okay. We could. Let me make sure it works on the second example too. 1, 2, 3, 4, and then DFS node dot left. Null back to DFS node. In order is left, node, then right. Yeah. Okay, so we just have to go through the array. I mean, go through the linked list. Fuck linked list. We go through the binary tree and get all the nodes and add them to an array. So like,
That's cheating, bro. I know. I thought of that answer too, and I don't think it's wrong, but it just seems like cheating.
yo,
But
this
continue.
guy is down to use math.gcd, but what calls this cheating? Okay,
No, I
okay, brother.
bro, do your thing. Do your thing.
I-
Math that is given to us. It's literally. I mean, oh
What's
no.
cheating about this?
I'm gonna let you think because you're like placing the whole tree in an array and like you're iterating it through it twice, right? It should just be a O event. Well, it's still an O
This
event
is
solution,
Oven.
but it's a big O event. You know, if that makes sense.
Two. It's just like, oh, it's 2 times n. It's 2n, but it simplifies to Oven. I don't know why you didn't just do that. Like, 2n is not really that much worse than n. So array to hold values. So you're saying this is too easy? It's too simple?
They even gave us a challenge of saying uh, follow up a solution of using O of n, which space is pretty straightforward. Could you divide constant O of one space solution? But let's keep going at it. Let's just make sure we could just get this first one on the
Oh
thing.
yeah, this is the Oven space. Oh, one space. No way. Oh damn. Yeah, whatever. Let's just do this. And then all we need to do is go what if we use recursive solution in the function which takes a node and put it in the right place? Yeah, that's essentially what we're doing. All right, yeah, so we just have to iterate through the tree in order and place values from the array. Right? Isn't that all we have to do is and then we just like return the root? So array equals this and then four, not four, what am I doing? I think it's return. See this real quick. See, does this work? Oh, I expected it to. Let's go, brother. Let me just do another DFS. DFS2 node and IDX for the index. And all we have to do is go in order. So DFS, not node, return. We just say DFS node dot left node dot val equals array at IDX. Yeah. Pretty sure I have to add IDX somewhere. Pretty sure +1 here, maybe. Where do I add +1? I think like
You want to add a +1 every time you increment or recurse?
if I did it right here, what would happen? Like call this, but if I did it +1, it would skip the 0 index.
Not when you recurse. This would still get the initial 0 index
Wait,
when you
but so you're
recurse.
saying do like recurse, so do this like +1 here?
Hmm.
But if I call DFS and then +1, this will be it's because it starts off at 0, so this will be 1. So when is it going to place the 0?
When it recurses back to 0?
Recurse it back to 0. Okay. So look at the first tree. Let's think. Because you might be right. I don't really. I just don't get it. So we go DFS node dot left, so it goes to 3. You tested it out. Left return.
Don't you need your null values to create a tree from this index?
Damn, it's almost right. Oh wait, I didn't. I'm retarded. I don't think so. I mean, you have to call DFS with root. I don't know. I feel like this doesn't make sense though. Does this make sense? Takes 2 arguments. Oh, DFS 2. I keep calling DFS. That's what I get for having 2 names to call DFS 1, DFS 2. Damn it, I knew it. Do we have to start this? I knew this wouldn't work. I think maybe you have to start off at -1. Oh, I got the first one right. Okay, so that did make sense for that one. The hell? Think about what's supposed to happen here. DFS node dot left. Comes out of here. That's the value. And then oof, very close. There's like a small issue. Hmm. DFS note dot left.
Can you explain why you don't need your null values for this, please?
Why would you need a null value?
To know
What
when
is
to
a null
stop
value
going,
gonna do?
to know when to stop going from left and right. How do you know when to stop going left or right?
Because the base case it just returns when it's not a node. Well, this doesn't even work, so like, I don't know. But let me like, if this works, then maybe I can explain it. But it doesn't really work right now, so like, you might be right. But I
I'm
feel
just trying
like
to
it's close
honest.
because I feel like if I explain it and it doesn't work right now, so it's hard to really like explain because it
Can
should
you
not work.
explain the logic between it then?
Oh, you just get the array. You get the you know the post order traversal will get all the nodes in ascending order. So you get them in ascending order, sort it, and then you go do a DFS on the original tree. And every time you do an in order traversal and you place the nodes one at a time. But I'm not placing the nodes correctly. So it should go DFS node dot left and all the way down to the left, and
But it will
then
get the,
place the one.
like you said, it will get the nodes in whatever order you want it. You're gonna sort it whatever way, right? Whatever way you like it. You're just getting the nodes. But how does it know like this tree structure? Doesn't the tree structure still needs to remain the same? Like,
Because we're iterating through the root. The tree, it's literally the same tree. We're not creating a new tree. So like
oh, I
it
see.
can't create any new
Yeah,
structures.
that was my confusion. That makes sense then.
Oh, okay. I don't know why it's not placing them correctly. I'm not doing this like increment shit right. Wait, what is it? I feel like this is not that hard. Like I feel a little slow. No. All right. DFS node dot left. So it goes dot left. DFS node dot left returns nothing, and it should place a one where the three is. Then array index goes up. Then it goes DFS node dot right dot left returns back up and places the two there. Damn. I wish I could figure out how to swap them, like just like the way it's intended to do. But yeah, why is this not placing the nodes correctly? I feel like kind of slow right now. DFS node dot left. Maybe this doesn't even need. Maybe that's like messing it up. Maybe I keep IDX global. You have to non. Yeah, you do have to non-local it.
You want to take it out from here too?
Yeah, yeah, yeah. I think maybe because the recursive calls are fucking it up, and I'm like, I don't know, not able to trace it. Non-local IDX. Then I can just do IDX plus equal one. This should work better because it's what the fuck. Oh, that okay. Come on, yippee yippee ki Yeah, this works perfect. I knew it was like something with the recursion. Okay, now we gotta figure out how to actually swap the nodes the right way. You know how to do this without like having an outside IDX? Because I couldn't figure out how to do it with the index inside of the thing.
I thought I would do it too, to be honest.
But now we have to figure out how to swap the nodes. Alrighty, let's think. You know that problem validate BST where you have to like tell if a BST is like a BST?
Hmm.
What if we just did that? But like every time we found a node that violates it, we like stored its reference somewhere, and then we just swapped the values at the end.
Say that again. Was the
Like
was the
so we iterate through the BST and we use the like validate BST algorithm. So every time we see a node that doesn't it like violates the BST, then we save it somewhere, like maybe I don't know, an outside variable called like node one, and then once we find the next one, we call it node two, and then since there's always two nodes that are fucked up, we can just swap them at the end. Not swap them, or swap their values, and then return the root. And that's off and like only one time around.
That sounds good. That sounds like a valid solution.
Yeah, all right. So I guess we can erase this. Alrighty, let's do it.
Go ahead, node one.
Oh snap! Appreciate you guys joining the stream. I like y'all. Good luck on your exam, my friend. So node one, node two equals none. I guess like call it like no, not DFS. Valid. So this will validate BST.
Now are we confirming? Well,
Oh shit! I think we need a low and a high.
why?
Basically, to validate a BST, you have to you have to see if the node is within the current bound. So, like in the first example, if you start off at one and you go to the right, the lowest a node can be, or the highest a node can be on. I said right. My bad. I meant left. If you go from
I
left
thought
from
we did
one,
an equation where, I mean, a solution where we didn't need it to do this low and high thing, where we could just optimally check the parents and the child, and that worked within that range.
oh, I mean, if you know how to do it, you can implement it.
I mean, you just check the parent and the next value, right? Or the
No,
previous and the next value, the previous
no,
value and the current value.
no. Check the value versus the low and the high, not the parent value. Because like what if a
I'm not saying your
node?
equation is wrong. I'm saying that there is you don't have to do it
Oh, how do you do that?
by just checking the previous and the current value.
But
So
what if
let's say
there's an okay?
let's say you had the three and and if you're at that three, check the previous value. If it's greater than or is it less than, then you would say that there is a wrong value here, and then you would take that as the first value.
So you're gonna so you're saying go in node and have parent, node and parent,
You could say parent.
and you'd have to have like, and wouldn't you have to check if it's the left or the right, so you can know if it's less than or higher than? So you have to node parent and left and right.
You remember the last problem we did where they somehow did not needed to check if it was the left or the right?
But that was deleting nodes because they just returned a tree that didn't have it. We're not deleting anything here, unless you could like.
We don't need
I
to
don't.
delete anything. Mm,
Wait, hold up. Forgot to do this. I think it's just like if node dot val is less than low, greater than high. Oof. I think we should make it like an array because I wouldn't know like which one to assign. You know what I'm saying? Like one or two.
what do you mean? What do you mean?
Like if we find an invalid node and we set node one to that, and then we find the next invalid node. Oh, you have to. That means we just have to do another check. Like if node dot one is not null, set it to this.
Exactly. Yeah.
Wouldn't it be easier just to have an array and then like just append? Then it's only one line. I mean,
Sounds like
if
easy, but I mean, it works either way.
node dot one.
You just say if not node. That's what I would have done.
Well, not, yeah, if not node one. If not node one, then node uno equals node. I think I gotta do it like I think just else. Something like that, yeah. And by the end, it should have two of them. Yippee ki Oh, we need a base case. And then I think we just have to call DFS. Like I said, DFS valid on node dot left. If it goes left, hold up. Can it be equal to? There's no nodes that are like the same value, right?
No.
So if we go left, that means that the high should change. The highest that node can be is low, I think. Wait, no. The low would be node dot val. Fuck, no. That's not what I meant. The high should be node dot val. And what should the low be? The low would just be the same, I think. So we go to left, the highest the like three's child could be is node dot val. And then we go node dot right. If we go dot right, then the lowest that can be is node dot val. Oh, let's see if this works.
Gotta change.
Print. Oh, yeah, make that one. That should be low. It should just be high. I think we just print node one and node two. Node one, node two. Will they equally to? I have no clue.
Gotta call your function.
Oh yeah. Valid, and we say root. And I guess like low, I'll just do like float negative infinity. and high. Just guess we just make infinity. Can I access node? Oh yeah, non-local both of them. I guess that were yeah. I guess yeah, an array would be cool there. Local, non-local. Can't spell for shit. Local node one. Oh, there we go. I got 2 and 3 for a first. Is that what it's supposed to be? Wait, let me do Daval. What? None type has no attribute val, so one of them didn't get assigned. Yeah, I thought that would be an issue because it if the node that has to get replaced is the first node, it won't work. God damn it.
So can we try this in like in order?
Wait. Oh. Go in order. So you're gonna go node dot left. Does it, what is that? How does this differ? So you go node dot left, and then wait, how does it get the root value though?
Well, the in order doesn't do the root first, right? We do like
The yeah, I think that's good. Why didn't it work? Something didn't get assigned. Unless this is not correct. Maybe you gotta run the test case. Maybe do delete test case or delete test case 1 and just do 2 because I know that that one's not the. Oh shit, they're both the root. Never mind. Damn. There's an issue with the whole root thing going on here. Why doesn't this work? I thought in order would have fixed the whole thing.
yeah. So what happens here? So like we go from the left, our low changes, high changes. With no dot vowel, so less than low.
Infinity. Negative infinity.
It is, right? Wait,
No.
no, it's not. But our 3 is greater than our 1, correct? So this should run.
We go to the left
If we
and
had
I feel like that's the wait, our 3 is
so we get
greater than the 1. Oh yeah, that should run.
we get
So that
node
gets to
1.
3. So how do we get node 2 though? Or node 1? Because I just grabbed node 3, right? Because you just went to the left.
Yeah.
Okay. So the
Then we'll
one
try
node.
the right, no, the right traverses to
Two?
nothing. Nothing. Yeah,
Wait,
it
what?
goes to the two. The two grabs nothing. Then we'll try this, right?
Yeah, yeah. And then should go back up to the one.
Does it see anything here? So what's the values that we have?
I don't think the
Uh,
low and the high would have changed because already it's back at the top. So like it would be the old values of low and high, not the ones from deep down. I have an idea. Wait, no. Can't we just do like I'm thinking just make an array and then add the node to it. If the array is of length one, then we know that the other one has to be the root and just add the fucking root. What do you think?
how does that help us?
It would get us both the nodes. Because
So
like
get us the value, but how do we compare them?
compare them to what? What do you mean? Fuck. When you say compare, like yeah, what do you mean by that?
Because don't we need to know like which one doesn't replace or not?
But like it should get the first. I'm thinking it should get like you saw the one got the three, and then our array should only have one value, and if it has one value, we can deduce that the other one has to be the root, and they just set that one to root, and then we swap them. I don't know if this actually works though, so I mean, take everything with like a pound of salt. Let me just comment this out for now, and let me just print array, well, length of array. This should be one. This should be one. Yes. Then we can just say if length of array equals one, array dot append root. Now we can do. I think we just do like array. Can we do an in place swap?
Yeah,
Like array of like zero. No, but we can't. We don't. We want to replace the values, not the actual nodes, though. Dot. Do I do one dot val? No, 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 no. I don't know.
you can do that. Yes, you can. If it's a node value, yes, you can.
Yeah, if yeah, array of node dot val and then array of one dot val equals the same shit but reverse, and then return root. I feel like this is like really stupid looking. Wait, oh damn, I used an array. I'm retarded. This doesn't mean yeah, it works. It doesn't make sense though because it doesn't use all of one space. Wait, no, it does because the array is only going to hold two values always. Yeah, it does use all of one space. I mean, yep. Let's go. Fuck, it doesn't work. We passed 470 test cases. Yo, have a suggestion for a beginner to start Leetcode, please, bro? Go on neetcode.com. Do some easy problems. Dude, what do you think? Are we cooked?
Uh, you mind if I try a different approach real quick?
Go for it.
Can I take this out, or you still want to try some other stuff?
Uh, it just messed up the. It literally just messed up example one. That's the only one. It did example two. Hold on, let me wait before you delete that. Let me. I want to see what does our array even have in it. What does the array have in it? It should have 1 and 3. Print array of 0 wow and array of dot. Why did I push submit? I meant to push run. Okay, it got. Oh shit! Nah, it got 3 and 2. Yo, why would it get 3 and 2 though? Does this not make sense?
For what example?
The first one, it counted 2 as an invalid node. This has to be wrong. Counted 2 as invalid. Oh, oh, technically it is invalid because it's less than 1, and it shouldn't be on the left side of 1 because it's greater than 1. Damn, damn. Yeah, you can go for it, man. I don't know. Because technically, the first one has 3 nodes invalid. They're all messed up, but you only have to do 2 to fix it.
Uh, I will keep the array, and I'll just go around it. I think I'll have a none, and I'll take this out.
Okay, let me just copy this. Or you can change whatever you want.
Mhm.
Did I just delete something? My bad. I'm gonna get this function back.
You want to return something here?
Oh, damn. I mean, yeah, you know what? We did solve the problem. Did solve it.
Yep, yep.
I mean, I'm sure there's a way to like just call the function and it like literally does everything. Like does the whole swapping and all that stuff. How do you the real problem is how can you tell if the root node is the invalid one? Like what are you doing to solve that?
Ooh, door. 1 second.
Oh, this shit's ridiculous. The root node. If the root node's fucked up, man. Maybe the idea he had with the pre-order, post-order stuff is good.
The idea basically is like you know still the in order approach, because if we have the in order, we can tell that if the in order is like the in order will get us the root value and then compare it to everything else. If it compares the previous, which is the root, to whatever its children is, or grandparent or whatever, then we we can say that that root is not the right place with that previous value.
Oh, see, that may work.
I'm sorry, did I take out secret stuff? I apologize.
No, it's all right. I wasn't doing anything. God damn it.
Okay, so that works. So I guess that's good enough for me. You ready to move on or?
Yeah.
All right, let's go somewhere else. What you got next?
Oh,
Be right back. Pick up the package.
all right, go for it. Go for it. Breathe. Breathe and pre.val. If pre.val is less than no.val. So how does this work? Wait, did I remove something? Oh, split return root. Remove all of this. You don't need this print statement anymore, right?
No,
So you have a prev, a node, and a. You have prev and two nodes. And if prev is none, you change it to node, and then you continue. So it should go all the way down to the two. No, it should go all the way down to the three in the first example, and the node should be three. And then you say, hey, if three, which is a node, and if prev.val, so it's three, is greater than node.val, they're both three. So that doesn't happen. And it goes prev equals. Wait, how does this work? Prev.val is greater than node.val.
so the previous value, not the current value. So like if you're doing, the traversal, the previous value in the first case would be none, and then we have a current value of 3. Then we recurse,
To the right?
yeah, where the
Oh,
previous value was a 3, and the current value is now a 2.
and if prev is greater than. So two is. Wait. Yeah, prev.val is greater than node.val. So we set node 1 to equal prev, which is a 3.
And node 2 is equal to 2. But then we recurse even more, and I mean, we backtrack even more. We say that our previous is now 2, and our current value is 1.
Yeah.
So is 2 greater than 1?
Yeah.
Yes. So then we say our node.1 equals prev,
Is 2.
and our node 2, that node 2 is now equal to node, which is our uh, root.
I see. Oh, nice. What is the next problem? I'm scared. If I push the random button, I feel like nothing good's gonna happen. It's gonna give me some really hard problem. I'm gonna just be sad.
Oh, path sum 2.
You said what?
Path sum 2. Have you done this?
You haven't done that? I feel like we did that before.
2, not
Yeah,
1,
it's
but
literally. Oh, I thought we did both. Honestly,
oh, it says I haven't done it. It says I only done path sum 1.
I'm not gonna lie. I'm pretty sure that question's like you're gonna just like breeze past that question.
Oh, you've done it already?
Yeah, and you could read it. Yeah, I know that's gonna be so easy for you. You can probably
Appreciate it.
solve that while I'm looking for the next problem. I'm still in the room though, so I guess I feel like I'm pretty sure you got that. Good old backtracking.
All right. The 1 hour rate. Mm, let's keep it total.
Yo, you're cooking. Like you're supposed to be like a 3 minute solve. I'm looking at this easy problem, and this is not easy. How's it going over there? Bro, it's XOR. It's XOR.
Oh,
But it said
I don't
easy,
know.
so I was like, oh, fucking 5 minutes. Nah. It can't be that hard though. I feel like once I understand like what it's asking. Yeah. Nah, bro, this XOR shit's ridiculous. What's going on over there?
For some reason, I'm not getting a path. What am I doing wrong
Like not like it's not generating a path at all?
here? It's missing. Well, I'm getting two cases right, which are like the easy ones, but like it's not getting a straight path down.
A minute, let me see. Oh, you got like what is that? I can't see the tree. But it seems like way too many nodes or something.
Yeah,
Some spaces in between them. So if not node, then total plus equal node dot val. Array dot append node dot val.
this needs to be temporary. Oh, oh, oh.
Are you popping it off?
Yeah, I'm not. That's the issue here.
Oh. Just do that thing where you pass it in like inside.
Yeah, I did that in the beginning.
Oh.
But let me try it again.
But you wouldn't need to. Oh, so you're saying you didn't have this before?
There's a thing where it misses like yeah, this also gives me like I would miss a value here if I did this.
Oh wait, so remove that then and just do it inside of here. Oh, what if you go over the value? Like, do you have like a stop clause? Because right now you only have if it equals it.
Yeah, if total is greater than some.
Yeah, I think this should be good. Hold on, now I'm like, what? Okay, how does this not work? If not node or if total is greater than target sum, then you return. If total is equal to target sum, you just res up and array dot copy. DFS node on left. Give your array. Oh, I. All right. Look at the first example. Like, what do all the paths have to start with? No
The
matter
root.
what. Yeah, but like, think about how you're adding the root.
Yeah, we added in here, but I've tried adding in here and that also didn't work.
Is there another place you can add it? Since like, if all paths have to start with the root, where else could you add it?
It is all answers? No, there could be some that doesn't have
Oh, what?
an answer
Oh,
targets.
yeah. But all paths have to start. So what happens here so far? Like the way we have it now.
So right now it's going down tree. So we say if total equals target sum. So res append array cap. So that doesn't work. So we traverse. We make our array equal to node.val. We grab the root. Then we try it again. Our total is 5. Then we'll do a 5 plus 4, 9, 11, and then 7. Why didn't we grab the 7? Because we did a 5, 4, 11, and 7. We grabbed the 7. Maybe I'm skipping something.
Well, you grab the
We take
7, but what's 20 plus 7?
27. 5 plus
And what
4
happens
is
here?
9. 9 plus 11
20.
is 20. 20. 20 plus 27. So this says go back 1 and try the 2. So this should be 22. Our target equals sum. We should grab the 5, 4, 11, and 2.
Whoa, pause, go back. Say what happens again? With the 2?
We go back
What happens with the 2?
we go we grabbed the two, no?
Yeah, we
We
got the
add the
two.
dot 11.
And where is this going? What is node dot right?
Oh, it's a none. So I also tried that. So what if we did add it here, it may grab extra paths, no?
There's a. I don't want. It's literally one line. Like think about it. It could be the default value if it's always gonna be there, right?
What do you mean?
Like if all paths have to start with the root, why is the root not always in the path before you even run the function? It should always be there, right?
You want me to put this right here?
No, just like that.
Is that our issue, though?
Now when it goes, it'll have root.val. So when you go down DFS node.left, what's a possible fix? You have to fix something else too, but maybe not. Maybe not. Yeah. If you want to go down that path, you just have to change like another thing, and that's it. But there's other solutions.
Because our issue is not our issue is that it's missing the two, no?
Yeah.
Well, it did catch. Well, no, yeah, it's missing the two. So like,
Well, it
if
adds
I
the
add
two, but it returns null first because you hit the null value.
exactly, so we
Yeah.
could do a check here that says if it's equal to that, but then we get dupes or
But you would get a duplicate. What happens if you put this first?
gets more than it should. So like,
Oh,
yeah, it gets doubles.
oh, I see.
I mean, a quick fix would just be to do a set of this. But what else?
It's really
Uh,
like around here because you're going DFS node dot left, but your array only has the previous values. It's like one behind.
what?
You want your path to have the current value you're on. You go dot left, but their path would only have you just added val, which is the previous one. It's one behind. Like how do you make it up to date? So the current node you're on has the path including that node.
So you want me to include the dot left? But what if it's a null? The dot left is a null.
I mean,
But
can't.
let me
Yeah.
fix it real quick. Real
Oh yeah, I'm
this.
sure there's multiple fixes. That's just the way I did it.
It's very inefficient.
Back to this shit.
Let me see if
What?
this works.
What the hell? How does this even work? It says that Leetcode easy. So I'm thinking like what node? So we're supposed to make this dumbass output array, and it has a 4. And an array is built off of doing the first node XOR the second node. So 4 XOR what equals 6? How the fuck am I supposed to know that? Or what's 6 then? It'd be like 1, 1, 0, which is wait no 4, 5.
No,
No, 4,
it
2.
needs to go down a valid path.
Yeah, that would be 6. But how do we get 2 from that?
So if you go back to what you were saying,
Yeah.
let's pick this up. and optimize it if no dot left.
Yeah, man. XOR 2 equals 6. XOR. Can we do. Oh, wait. I think this is it. Not you. If you. uh, so we just do 0, 0, 1. XOR the first one. Just 4. So it'd be 1, 0, 0. And we get 0, 1, 0, which is 2. Boom. It would go 6. You got it?
Nope.
You want me to tell you, or you how you feeling right now? I thought you're like super close though. Let me see. What's going on here? I like what you did here with the root.val. If it goes over, return. If it's not node, return. Append the copy. If not, if no dot left, you do no dot left, and then you do array plus no dot left dot val, and total plus equals no dot left dot val. Let me see what happens here, because this looks pretty good. The first one's wrong. It gets you outputted 5, 8, 13. 5, 8. What's 5, 8, 13? What?
It's a
5, 8, 13 is not 20, is not 22. Like your total can't be counting correctly. Or something, because
right.
yeah, 5
Oh,
plus.
because this is a right.
Oh yeah, because this looks perfect. This has to be just a small issue. Yeah, there you go. That's right. Well, at least the
Something's
first
wrong.
three are. Oh, was another one wrong? Oh, edge case, just an empty tree.
There's something else. For there's a tree of 1, 2.
Oh, do you have the if not root though? If let me try this again. It wants you to output 1, so it's 1, 2. Target sum is 1.
Saying the root alone can't be the So it needs to be a end to a leaf node, start to a leaf node. It can't just be. So uh
Wow, maybe this question is harder than I thought. What the hell? I don't remember. I did not remember all these edge cases. Oh, you just need to change your base case.
yeah. My goodness.
Did you? I don't know if you thought it went through because it's like if not node, that mean it could be like a null node. That's too far down. Like that could never happen because it has it. You have it right here if it's greater than or if it's not.
Yeah.
Like think about right here. Yes. Oh, you stopped. There you go. Why do you have an or here?
Catch.
All right, this looks good. I'm betting my money this one works. Let's go. Wait, no fucking way. You're lying. There's more edge cases. -2, null 3, target sum 5. Is it not adding negative numbers correctly or something? Oh, because you have totals greater than target sum. 0 is greater than -5. So just return. It
Oh,
wouldn't even traverse. There you go. Yippee ki Oh snap! Oh, wait, no, we got 10 minutes left. We could we could do something super fun.
sounds like a graph problem. Whoa, nope.
Hey yo, chill, dude, chill. Doing them easy problem. I'm gonna send it over right now.
It was the thing you just did, and now you're giving it to me to do.
No, I didn't do it. This is different. I solved the other one. I've never even seen this problem. You're given an integer n, an integer start, define an array where nums of I equals start plus 2 times I. Return a bitwise XOR of all of elements. What? Given an integer n and an integer start. So like they just want us to go until the res is equal to is less than n. I feel like that's what they because they have to fill this array up. I'm guessing.
Wait, I don't understand the problem. How are we get array nums is equal? So what? How are we getting these numbers? 0, 2, 4, 6, 8.
Because it says that
Um,
array of I equals start plus 2 times I. So if start is it's always gonna start with
what,
0.
what's I?
Wait, no, I is the index. But the second
What's
one
our
looks kind of weird.
what's our end? So why did we stop at 8?
At
0. Oh,
8,
because we have 5.
yeah,
0, 1, 2, 3, 4, 5.
yeah. Start plus 2 is 5. I don't get the second example. Why is the first one not 0? Because isn't any number times 0 0?
Hmm?
Isn't any number times 0 0?
5, 7, 9. What do you mean?
Like like the formula for nums of I is it's equal to start plus 2 times I, right? And look at the second example. If start is 3, 3 plus 2 is 5 times 0 is 0. Why is that a why is the first number in the array not 0?
Order of operations. 2 times 0 is 0.
Oh, and then plus start. Okay, okay, okay. I feel you. So don't we just go until the array is like filled up with stuff?
I was gonna do this, So I'm gonna fill the array or create the array, and then we can do the bitwise operations.
You're gonna create the array like in one line?
Yeah.
Oh, brother, let me think about this before you do it. How the hell do you do that? So you just say like for. Wait, can I try it for you? Because I know you're gonna like ace it. It's like
Yeah, we
array
already have the formula, so we just yeah.
array equals start plus 2 times I. I don't think I have to put in parentheses because I guess Pem does just like figures it out. For I in range n plus 1? No, n. I think that's how you do that. 0, 2, 4. Hell yeah. Okay, cool. Do you want to do the XOR thing? Oh, you got list comprehension too. Yeah, makes sense.
Wait, I'm gonna try. I failed last time with bitwise operations, and my lesson is I can't do it. All right.
My lesson is I can't do it. Okay.
Does that look right to you?
Yeah, it looks good. I think that's right. I don't think there's any tricks because it's an easy problem.
Wait a
Let's
second.
go.
Can we not one line this? Let me see.
I
Let me
think
think about
so.
it. Let me think about this.
I think you just do the sum, dude. Just do sum.
But it's not a sum though. It's a bitwise operation.
Oh,
I'm gonna ask the LLM.
Yeah, I was thinking the same thing. I was like, I don't think we're gonna derive the solution from this. Oh, hell no.
What happened? What happened?
It's telling me you gotta import func tools and
So that's a
like,
no. Apparently, no.
yeah, like, nah, I'm not importing stuff to do that. No, thank you. Uh, yes, I guess there is no XOR sum operator.
Yeah. Okay. All right. What else? Good to know.
Yeah. Oh, that was see, XOR is not even that bad. Granted, we're only looking at easy ones, but who cares?
Yeah, I think when you're not telling us to explicitly use XOR, then and we use it, I think for any bitwise operation, then I think that's when we could say we're good at it. But now it's like in the easy, it's literally telling us what we have to do. So
It kind of, yeah, low key, the description literally like just as a step by step of what you have to do to get this answer. Fair enough.
now what we got next?
Yeah, I want to do one more. It's this one's medium, but it has like 88% acceptance. So I think like it can't be that bad. I invite you right now. Give an integer array pref of size n. Find and return all the array of size, and that satisfies. Give an array of size.
Oh, you went up to medium? Okay. All right.
No, it's just because I just went in the high in ranking of acceptance. This is 88.2 acceptance. So array of I equals 0 up to I. Okay. Find and return the array of size n that satisfies. Fuck.
Yeah, how'd we go from 5 to 7?
Oh, because 5 XOR 2 XOR 0 is 7, I think.
But it just says what?
Wait,
So wait, what? What? So prefix of 0 equals 5. Did we do any calculation there that I missed? So we just get 5, right? And then prefix of 1 is 5 XOR 7. This 7 magically appears. I don't know where it came from. Do you know where it came from?
no, because prefix of I is 2. So we need to find, and we already know
Wait,
what
what is
5 output of 0 is. So 0 to 1, like XOR 5 XOR what equals 2 is really the question. And then that's where it got 7. We have to figure that out to get the 7. We don't know the 7
Oh, but why didn't it do the same thing for index 0?
because
5.
prefix of 0 equals prefix equals array XOR, but there's nothing else to XOR. There's only one element because there's nothing that comes after. There's nothing before 0, so it has to, like, the first element's always just going to be the same in both arrays, no matter what.
I understand what they're saying now.
So I feel like I'm not like writing a solution, but I think
Is
res
this
is just going to have pref of 0.
is this a BST solution? Because I can't. Is this no array bit manipulation? Mm,
Oh my god,
how do
how do you read the question? It says array prefix of XOR. He goes to graph, bro. He goes straight to graph. How?
no binary search is not graph. It's
Oh, they said BST, like binary search tree.
oh sorry. Take out the tree.
Oh, okay.
Because how do we efficiently find 7? Is the question.
So what do we know?
Is
Like we
there a map?
know 5, and we know we need to
Get to.
wait.
So is there
We know
like a
we need to
map?
get to 2. So what's 5? What's 5 XOR 2?
I don't know.
So 5 is 1 0 1, and 2 is 0 2 1. And what are these equal XOR? 1 1 1. So that'd be 4 5. Wait, no, 4 5 6 7. That's it. 5 XOR 2 is 7. And then we just know that's what it is. You just have to XOR the first 2 ones, and you'll get the other one.
So the formula is 5 XOR or the previous XOR the current to get the next one. Okay, so
Yeah.
we have a 1 in total. That's what it looks like here.
Now I'm guessing that'll just equal like res of 0, because it would equal the first one first. Let me keep that here for now. I think we need a for loop that goes.
Mm, uh, can we not do this? It makes it much more complicated. Can we just get it start from the beginning?
Sure.
Wait, is XOR 0? 5 XOR 0 just 5, or is that still
Yeah, at 5 XOR 0 is 5.
okay?
Don't you need I though?
Why?
So how are we gonna fill up our res array? Oh, we're just gonna do it one at a time. Total XOR equals val. Oh yeah. And just append return res. Wait, does this make sense before we run it? So we have, so the first one will be 5, and then we'll get, and our total will be 5, and we do 5 XOR. The next one is, it would do 5 XOR 2, which is 7. That's when our total is 7. And then we do 7 XOR 0, and that'd be 0. Yeah, that literally makes perfect sense. Fuck. Okay. It only worked until we traced it. After that, it doesn't work.
That's crazy. That's what
Um,
you get for being.
yo, dead ass. Dead ass. Okay. So we got 2. We got 7
Maybe
again.
maybe saying that we can't just do them in total. Like this may equal a different number that the 5 7, which will give us what? What does that give us?
2.
Is there a calculator for this? So we have to do this manually?
What it says in example 1, just look. It says 5x or 7 is 2.
Oh, and 2x or 2 is 0, right?
Yeah, 2x or 2 is 0.
No, we're doing we're doing
Oh,
2x or 0 with 2. 2x or 0 is 2. So why didn't we get 2? Why didn't we
no
get
clue.
2? Right?
The Wait, this equals 0? So if it equals 0, wait, why does the output not have the 0 in it? No, this is kind of confusing. Maybe I don't understand the question. So we did.
Uh, can I do a print if you don't mind?
Okay, go for it. We do 5 XOR 2 is 7. So we put that in there. And then we need to do 2.
Oh, it's what's 7x or 7x or 0 is what we're doing?
Wait, what?
Wait, what?
That word. Oh, wait, what?
If you print it says, so we have our 5. 5x or 5 is 5, right? X
Yeah.
5x or 0 is 5, right? We get this. Then 5x or 2 is 7. 7x or 0 is 7. Okay, that's how we got 7. 7x or 0 is 7. We should, yeah, we incorrectly got 7.
But this should be 2. I don't think we. Wait. What? So 5 XOR 2 is 7. Then we should do. Wait.
7x or 0.
Wait, no. Well, yeah. 5 XOR 2 is 7.
Yes.
So we do 5 XOR 7 equals. We do. Yeah, now we need to know 5 XOR 7 XOR what equals 0. That's what we need to know. So we just need to do 5 XOR 7 XOR 0, and that would be the answer. So when is our total? Yeah, when our total is.
So why don't we just do that in every calculation? Because apparently we can't use a total sum of our previous ones, if that makes sense. I think that's really the true issue here. It's like,
Yeah. I think you just set the new total. So the first one we do.
wait, how do we even do that though? Like,
I
because
think
like,
that's. I think like the thing I had of like setting this to proof of like may work. Because now if we have total already equaling to the first one.
but that's not our issue, right? Because the first one does work, right? The first one correctly gets the 5. The 5 is set correctly, right? We have our 5.
Yeah. And then we have to do yeah. This is I XOR shit's kind of crazy. Five XOR what is two? 0 XOR 5 is 5.
We just missed the 2. Why do we do another 0? Oh no,
5
that's what we're
XOR.
supposed to do. That's our formula. Our formula says to do this from what we got. So maybe that's not the formula? I don't know. Maybe our formula is just wrong and like understanding like not exactly how we get
Yeah,
like
because
this
it says
thing.
5 XOR 2 equals 7. And then we need to do yo what?
So is 5 XOR 7 XOR 2 gives us 0?
Yeah,
Does it really?
yeah. It's 5 XOR 7 is 2. Then 2 XOR 2 is 0.
Oh wait, the question is how do we get the 2, right? How did we get the 2?
Get the 2 in the second one. Because we did 5.
Doesn't that
We
just
did
make sense?
5 XOR 2.
No, no, like to get the 0, how did we get the 2?
Oh, because 2 is the. You're talking about the where pref is 2, like the
Like
second
2?
index?
Yeah. Yeah, 2.
Because I don't know. We have to. That's our job to figure out how the fuck do we get a 2. Oh wait, no. So that means we already have 5 and 7, right?
Yeah.
So don't we just have to do 5 and 7, and then we need to know 5 XOR 7 XOR what equals 0.
Yeah.
So we just have to do 0. Yeah, we just have to do 0. 5 XOR 7 XOR 0 would be 2, and that's what we need.
No, but that's what we're doing, and we didn't get it. No. Oh, yeah.
I don't see that. Wait, can you? I don't see that here though. Like, where do I
Because
see 5 XOR?
5 XOR 7 is what?
It's 2. Like I don't see 5.
5x or 7 is 2. Yeah, why don't we have 5x or 7 here? What's
Because they're doing the vowel inside of pre.
shit? It seems like step 1 and step 0, step 1 and step 2 are different. I don't know. That's not consistent. That's what I'm thinking here. I don't know.
Can,
What are you thinking? What are you thinking?
this is not. I feel like it's not that hard, but like the logic, it seems so easy, but it's not easy. That's kind of the
Yeah,
problem
yeah,
here.
yeah.
What if we like?
These numbers are throwing me off because they're like, I wish there was like a different example to look at. Because the 2 and the 2 are not the same 2, but they look like they are the same 2. So um, you were saying something?
Oh, I was like, so prefix of index 2 we see as 0. Where do we get our 5 XOR 7? Okay, so that's our example. When we have 5 XOR 2,
Yeah, we got a 7. Then
now,
take 7 and then we do it to the next value in the prefix. But they're saying that we should have used the 5. Oh, the 2 is a magic number in which we need to figure out. But to get the 2, we said that we usually will use what we currently have in the 0, in the 5, in the 7. So wait, the 5 and the 7 gives us a 2, right? You said?
yeah,
And we already have the 5. Maybe the formula is to do what's in the array already
yeah,
times, I mean, XOR the 7, XOR what we have, and then XOR the next value. Would that then give us our 0, our 2? So it would have been like 5, 5, up 7, up 0. Does that give us
yeah. It gives us 2.
2?
Yeah, yes,
Yeah,
that's
so
what we
maybe
need to
for
do.
its calculation, we do like what's in our current array, XOR,
Vowel,
yeah, right?
yeah.
But we need to, but we can't do it in like a some kind of way, which is confusing if we can do it in a some kind of way, where we use like this shorthand. Let's do it in one line. Does that make sense to do it in one line?
Um,
I don't, I don't if we can use the shorthand of this, which is what that's what's truly confusing here, no? If we can,
yeah. I don't know. Wait, can we just fill up the array and like do it the slow way? Like we just iterate over the array again, XOR everything up, and then do the next one. Like it's slow, but like, I'm pretty sure that works.
what do you mean?
Like we could just can't we just start off with proof of 0 and start this off of res of 0. So now total is 5,
Okay,
and then for the first iteration, we just say we sum up, we XOR all the totals inside of res. In this case, it'll be 5. 5 XOR 5 is 5, and then we do the sum of that times pref of I plus 1. So in this case, it'll be 5 XOR 2, and then we add that to our output, and that'll be 7.
I don't understand, but write it out, and y'all understand why you're doing it.
So
You want to remove this? We can delete this. It's no big
yeah,
deal.
maybe we can delete that. So if we have res,
Mhm.
of like wait, hold up. So yeah, so res equals 5, right? And I think this is it. Total equals 5 as well. And then we iterate through the prefix thing and we say, hey, sum up, well, res is an array. So XOR all the elements inside of res. And I guess we haven't, let's pretend we're like iterating through prefix and right now we're at 0. We say res, XOR everything in res, that'll give us 5, right? And now we say whatever that outputs, XOR
Yeah, but
that times,
that was our issue, right? How do we XOR everything in res at the same time?
just have a helper function. I'm saying it's
But how do
slower, but it 100% works.
we do it mathematically? Like, how do we do it? Like, not the whole. You don't have to write the whole function. Just that one step where we do the whole um XOR.
Like, like, like this, and it takes in an array, and then whatever this returns will return the whole entire thing. And then we just call that function every time. It's slow, but like I think
But how is
call
that
that.
different from just having a total?
Well, let's trace it. I don't know, but this makes sense so far. So we have res of 5, an array of 5. We sum up everything. We XOR the whole thing. It'll just give us 5. And now we say prefix of I plus 1 because we're at 0. We want to go to the next one. So we do 5 XOR 2 and then add that to the output. So now the output is 5, 7. We go to the next iteration. We XOR everything that's in our output. In this case, 5 and 7. That gives us 2. And then we XOR that times prefix of I plus 1. So 2 and 0 will give us 2. That makes perfect sense. That works. No?
Yeah, but I like our initial example did the same thing, but it didn't give us the right answer. No,
Because we didn't, I don't think we did I plus 1. I think that was an issue.
I plus one.
Because you have to XOR it by the next one. I'm gonna just try this really quickly and then we could do the other one because I just wanted to see if this works. So
Yeah,
I'm pretty sure you do for I in range length of pref.
yeah, starting at one.
Wait, no. Start at 0. I think you're supposed to do I plus 1. Then we just do. Wait, do we even need it? Wait, I don't think I used total. I don't think I used total. I'm gonna say T. T equals helper
Once you
of
just append it,
res.
right?
We append it. So this will give us our total. So this will be 5, and then we say res dot
Um,
append T XOR pref of
I
I plus 1. Why did I do it like that? And I think like there's an issue because this has to go like something like that. So this will go in.
okay.
It'll sum up our total res, and then we say res dot append 5, and what's prefix of I plus 1? That'll be 2. So and then 5 XOR 5 XOR 2 is 7, and then we append that to res. So now res should have 5 and 7. And the next iteration, we XOR 5 and 7, and that's 2, and then we do total, which is 2, which is
Mm-hmm.
the 5 XOR 7, XOR pref of I plus 1, and I is currently 1, so I plus 1 is 0. I think that works. And then that'd be 2. I think this is overly complicated because we could have just did I plus 1, but I think this works. And if it doesn't work, it has to be like I spelled
Oh,
something wrong. What did I spell wrong? Pref. Oh, I spelled it wrong again. Come on, it gets timing me out saying I clicked the button too many times. No way, I do it in all of them. Jesus Christ. Does it work? Please work. Please work. Please work. Please work. Please work. Let's
hey,
go.
what?
Let's go. Let's go. We're XOR Beast. I know it's super slow because we looped over the whole thing with this helper function. It's kind of stupid. It might time out actually, but I think the
Let's
fix
see.
is pretty obvious. Yeah, it's definitely a timeout. We did that like yeah. It's all good. It's all good. All we have to do now is don't use helper. And I guess we just do like total equal XOR equals. What do I do? What did I do before? So how do I do this? Total. I just say total XOR equals total.
Can we not say
I think we can
uh
actually start this at 0
can this be like the last one in the res variable? Because that's our total, right? No?
Is it? Yeah,
Because
yeah. Yeah. Total equals res of -1. Yes.
shit,
No?
no.
Dude,
That's
what?
where
Damn it. So
huh.
we have to figure out how do you do this shit, but like not the slow way. How do you XOR everything?
Do we have to use another bitwise operation?
Why is why can't we drop my camera? No more camera for me. Why is total not
What?
like why does total not like why is having a running total not work? If you're literally just because all this is XORing the last one. So having a total of 0 and then we just say total equals XOR of
Yeah, can we yeah, why can't we just like yeah, why can't a running total just work? Because we've done the running total of the
why can't total equal res of -1? So the first iteration is going to be it's going to be 5. And then we say 5 XOR 2, which is 7. We just appended 7 to res. So now we have 7. Now we say 7 XOR
XOR
2.
XOR 0?
Yeah, 7 XOR is Oh shit.
Wait, wait,
That would
wait.
be 7. That's not right. Yeah, that is the problem. We need the total to be like a running sum of all the XORs, not just what we appended last. So we do need this total thing. So what if we just did? I think you did this before, but we just didn't do +1. XOR equals I, not I. Pref of I. I think there's another problem here because yeah, I think we just leave this as 2. Res should be empty in the beginning because total will be 0, and then we XOR. Are we supposed to XOR? So we do 0 XOR 5 would be 5, and then we do total XOR pref of 1, which would be 2. So 5 XOR 2 is 7. Perfect. We append that on there. And our total should be 5. Next iteration, we go through and we say our total. So 5 XOR 2. We supposed to say 5 XOR 2?
Which one? On which
Like,
iteration? Prep one?
no, all right, so let's start over. So the first one, we have total is 0, right?
Mm-hmm.
Total XOR would be
Five.
XOR 5, which would be 5, right?
Mm-hmm.
Now we say 5 res.append. Oh, it missed the 5.
Yes.
So maybe res does have to have the 5 in there. So res has a 5 in there, and we say total, which is wait, what? Total XOR equals pref of I. Dude, what the Yo, do we ask ChatGPT? Are we cooked? There's no way this is that hard.
Maybe we use those fancy imports.
To sum up, yo, what the fuck? Damn, because XORing.
Yeah.
Why
How
does
do you?
total not work?
Well, we saw that. Yeah, that we're doing like only the previous and not like the total. So we needed to XOR the 5 and the 7 and the 0 instead of just the 7.
So, okay. Breathe. Total is 0. When we say total, so it'd be 0 XOR 5. It'd be 5. That's perfect. Next, and then we do 5 XOR 2 would be the 7. Boom. Res is looking beautiful. So the first iteration, it works. We say total XOR 2. So 5 XOR 2. No, this should not do that. If 5 should not XOR 2. 5 should XOR 7. You know what I'm saying? The second iteration, that's why it's wrong. It should not XOR 2, it should XOR 7.
You mean the? No, why? Shouldn't
Because
XOR 2 to
5.
get 7? Shouldn't XOR 2 to get 7? 5 XOR 2 equals 7? No.
No, I'm talking about the iteration after that.
Oh,
So our total is just 5, right?
yeah. Should XOR 5, 7, and 2? No.
Yes, that's what we want. But what's actually happening?
We're doing 7 XOR 0.
7 XOR 0. That's not what we want. Because 7 XOR 0 is going to be 7. We want
5 XOR
7.
7.
Yeah. No,
XOR 0.
5.
XOR 7, XOR 0.
Yeah. Wait. What if we just? What if we? What if down here we did like after we do it, we do total XOR res of -1. So whatever we just added, then it would XOR that. So do 5 XOR 7. Then when it comes up here, it'll be XOR 2 or XOR 0.
Say again?
Like, so what if we do XOR again at the end? So it will be in the first iteration, it'll be 5 XOR 7, and we'll append that on here, and we'll append 5 XOR 2 will be 7, and we'll append that on here. But our total is still 5. But after we're done, we do total XOR equals res of -1. So whatever we just added, so 5 XOR 7. So now our total is 2. So in the next iteration, we're going to have a total of 2, and we're going to 2 XOR 0, which is 2. And we add that on. I think this makes sense. I keep spelling
And then
prefab wrong.
and then 0.
I think this makes sense. I only got the right.
We got the 0.
Oh my god! It literally only works until where I trace it, bro. What?
And the 3. We just missed the 1. Well, let's say we should have gotten 2. So I guess it didn't get the 2 that we needed.
All right, bro. Holy shit! This is I despise this shit. 5. We got 0. They got 2. So what do we want to happen? First iteration total is 0. 0 XOR 5 is 5, right? Res.append 5 XOR pref of I plus 1. So that will be 2. 5? I said 3. 5 XOR 2 equals 7. So our res has a 5 and a 7, right? And our
Mm-hmm.
total is still 5. We want to do 5 in my head, right? We do total XOR equals res of -1. We just appended 7. So shouldn't this do 5 XOR 7? What's 5 XOR 7? It's 2, right? But they never equal 2. You like, is this not what happens?
Hmm?
Is this not what happens? 5 XOR 7 is 2. Shouldn't this be 2 here? So total should be 2 coming out the first for loop.
But bro, isn't the issue that we're not grabbing everything? So even if this worked, like even if it grabbed the 2, let's say for the first one, or the 5, or the 7, but what if there's like an extra one in the middle? Like, would it always grab everything that we needed? Because it needs to do all those operations over every single time.
But isn't this what? But total is going to be the running total, because if this is, let me think.
Yeah, but
So if
we
this
don't
is
want the running
2,
total, right? We want like every number separately and then do it every time.
oh brother, goddamn, maybe. Wait, all right, wait. So does this not make sense though? If this is 2, right?
Wait,
So the
hold on.
next iteration. All right, trace this. Tell me, does this make sense so far?
So total is 0. 0 XOR 5 is 5. Then we append total, which is 5 of 2. 5 of 2 is 7. We appended the 7, so we have 5, 7. total is still 5. 5 of 7, 5 XOR 7, where res is -1, is 2.
Yeah.
Then we go total XOR 2 again. 5 XOR 2 is 7
No,
again.
whoa. Where'd you get 5? There is no 5. It was 2. Remember? Because we just went before.
Oh,
It changed it.
2. Yeah.
2
5
XOR
XOR 2,
2 was
7
up here.
is 2. 2 XOR
2
2
is 0, right?
0
0 XOR 0 is 0. Wait, what
is
do we
0.
want to equal?
That's what you did get. You're right.
Fuck.
That's what you did get. But you wanted a 2.
Okay, what went wrong? What went wrong? So something was right here. So this is 2. We want 2
We
XOR.
we only captured this 2, but we passed the 2 and then we appended.
Is this like a counting error? Is there anything to fix this? We wanted to go 2 XOR 2. Wait, no, we want it to be 2 XOR 0. If this XOR 0 would work, we don't want it to XOR the current number, we want it to XOR the next number. But why doesn't it? Does the
So I took a look at this iter tools or func tools thing, and you can apparently do this operation in one line, bro.
what does it just show me?
And so like we can do like a are you committed to this thing? Should I do it on a new line?
Just delete it. Just fuck that. Wait, oh my god. If reduce does what reduce does in JavaScript, it's just as slow.
Yeah, but that's essentially what we need to do.
But that's the
Like
same problem that our helper function had. That is too
maybe
slow.
a more efficient way. I don't know.
I
I
hope
don't know.
so. All right, let's go for it. Yeah, I think we delete this, right?
Yeah, we don't need it.
I don't. I think it's on timeout. If it does runtime error syntax, what happened? Invalid syntax. Is it? Do you have to
Yeah,
do
that's him.
like functools dot reduce? Oh, you have to put XOR.
Oh, that gives me shit.
It didn't work. That's worse than our manual reduce. You know what?
One
I'm not
second,
gonna
let
look up
me.
the answer because there's no way I need the answer for this. But I might have to come back another time because maybe my brain's too fried to think of this.
Oh, yeah, it's that time.
Shit's not hard. Clearly it is, but it doesn't seem hard.
One second, I just need to think about this. Oh yeah, so we just add it to. Wait, the res should have this res plus um the next one, right?
Yeah. Prefix of I.
No, we want to start at 1 because we already have this. So we
Yeah.
do x or 5x or 2, right? That's what we do in the first iteration.
Yeah. Please
5,
work.
2.
Yeah, it works. It works. It works. I think if it, you're lying. No, no, it times out. Yeah, this literally does. This is literally manual. This is just a function that does what our helper function did. Well, the big challenge here is figure out how to do running totals. Running totals do not even seem that hard, but clearly is too hard.
All right, I am down for the answer, bro. Maybe
No,
I,
no, no, no. We just come back another day and try. How are you gonna look up the answer? This is possible for us. Maybe not right now, but it's possible. Do you really want to look up the answer?
it said yeah, it said we can
He
solve
said
this in
yeah.
1 month with a list comprehension, and I feel ashamed.
All right, all right, all right. But you don't think like, do you really think we need to look up the answer if like it's literally just a running total thing? Clearly, we don't know how to do running totals, but like
We do know how to do a running total. We just don't know how to do this efficiently. Like you seem that you've implemented the running total, but
that's not a
doing
running
the
total because it just redoes the total. A running total would be like having the same value and then like carrying it
done a
over, so you
count
don't have to
total,
do it.
and then we've done a run total every single time. So like that's what it is. We've done it in both ways possible.
We didn't do it
With no,
correctly though,
yeah.
so we didn't do it. Like we did it wrong. So what happens here? Prefix when we get to 2, it goes 2 XOR 2, which is 0, which is what we don't want. We want it to go 2 XOR. Wait, what? We don't want it to be 0. We want to. Oh, we want no. We want it to go 2 XOR 0, not 2 XOR 2. That's literally the issue here. When it comes to the second example, the second like row or iteration, we have our 2. We want it to XOR prefix of I plus 1. But the problem is, the first iteration we need to do XOR of the first one. So what if we just had
Can we
total?
do
What
like
happened?
a prefix of can we do a manual of prefix of 0?
Hold on.
No.
How does that work?
Because like I'm thinking, how do we catch? Because the first one is always included, right? And then
Why can't we just make the total like literally res of 0, like how we had before, and then start at 1? So if it started at 1, we'd have total, which is 5, and we have XOR. Yes, I plus 1, which is 2. Let's yeah, let's do that. Okay. So we have 5 XOR 2, 7. Boom, 5 7. And then we do we even need this anymore? Our total is total is yeah, we do. And then total XOR -1. So 5 XOR 7 is 2.
mhm.
5 XOR 7 is 2. So now we have a 2 here. 2 XOR I, in this case, I is going to be up 1, so that's going to be the 0. That's perfect. Should we? I feel like we should keep tracing just in case. So 2 XOR 0 is 2, right?
Mhm.
2 XOR 0 is 2, so it still stays 2. And we say res.append 2 XOR Prefix of I plus 1. That'd be the 3. This has to be I. We don't have to do plus 1 anymore because we started off plus 1. Is this even necessary?
Oh my goodness.
What?
Can we just do the prefix of the current one from the prefix of the previous one? The current plus previous, not total, but the previous. So
Dude,
prefix.
it works! I think I got it. I think I got it. I think I got it. Holy shit. Holy shit. Holy shit. This is the one. 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 Let's go, baby! This is what the world's been waiting to see! Oh, yeah! Oh, yeah. I don't get beat by these X4 problems. So what? It took an hour. I ain't look up the answer. Let's go. This is kind of embarrassing that it took me this long to write like 8 lines of code, but you know, we did it. We did it, man. This is a beautiful way to end the day. The issue was, like, we just need to start at 1. We were like doing everything backwards. We're starting at 1, then we do plus 1. But we should have just we started at 0 and did plus 1. We should have started at 1 and not do plus 1. We had it inverse. Oh my god. We did it. We did it. We did it. We did it. All right. You hopping on tomorrow?
Hopefully.
Uh,
That's a sadie.
how do you feel about that XOR problem though? Like we solved it, but don't looking it up. Like we actually used our brains.
Yeah.
What do you think of the solution?
It works, right? What was the one? It works, yeah.
But like, why did it take us so long to figure it out? Is it just because like we're new to XOR or like what? Like this should not take this long.
What?
I don't know. Maybe I need to know the intuition behind this.
The issue was just getting the total. Yeah.
Yeah. So you gotta append the total XOR I, and then you have to XOR that times whatever you just added to res. Whew. I feel like it's one of those things that we would have got a lot faster if we like traced the whole thing from the beginning and not stop after it was right one time.
Yeah.
We would have saw that it was wrong so many times. But anyway, I'm pretty happy with that. You know, I could end this day and actually I could end this day with a smile on my face. I did a medium XOR problem, no help. Hell yeah! All right, bet. So I catch you tomorrow, man. I'm gonna go running or something before it's like cold. All right. All right. Peace, man. Really cool. Yo, oh my god, that took forever.